Big welcome to today's webinar. This is the third out of 4 presentations in this series, which is being made possible as part of the 2-year project that we're running in collaboration with NatRe in the Philippines and many other partners in the Philippines. It's been funded by the German government International Climate Initiative of the Ministry of the Environment, and it's due to complete by the end of this year, by the end of 2020, to deliver a flood model for the Philippines on the Oasis open source platform. My name's Claire Souch, and I've been managing the project overall. I'm going to be joined in today's presentation by Mark Pinkerton and Ben Hayes. They're going to give an overview today of the Oasis platform architecture and implementation. So on the technical side of installing and running Oasis. Mark is the CTO of Oasis Loss Modelling platform. He's head of the development team and is responsible for all aspects of technical design and implementation. And he has over 15 years experience of developing analytic software projects across the reinsurance industry. Ben is the CEO of Oasis Palmtree and was previously the Chief Information Officer for Oasis. Oasis Palmtree provides consultancy and support services for initiatives relating to Oasis LMF, including implementation and technology support and services and catastrophe modeling advice. So this is the third of our 4 webinars. Previously, we covered the fundamentals of catastrophe risk models, inputting data, running risk models, and using the outputs. And all of those 2 previous webinars are available on the Oasis YouTube website. In our next webinar next month, we will cover the Philippines flood model itself, which is being delivered as part of the project. Please submit questions using the chat function to the host, and we will do our best to answer as many of them as possible at the end of the presentation. And again, a recording of this presentation and the slides will be made available afterwards. So Mark, I'm going to hand over to you and to Ben to take us through the rest of the presentation. And thank you very much.
Great, thanks Claire, and good morning everyone. Let's just go through to the agenda. So on this morning's call, I want to talk about Oasis architecture, how you actually go about building and getting models into the platform. So 4 broad areas. I'm going to talk a bit about the general technical architecture, the technology stack that we use, how you can actually deploy the components together into a system. And then I'm going to do a quick demo of how the sort of most direct route of getting up and running with a version of the system, that you could go away and try out yourselves pretty easily, and also have a bit of a poke around Github and where the various code and documentation is for you to kind of look at. I'll then hand over to Ben, who will talk a bit more about how we support actually building and deploying models into Oasis, and in particular the concept of the MDK, the model development kit, because as well as the, I suppose the more sort of business user, model user focused application, we also have a suite of tools very much focused on the model developer use case. Okay, so getting into the architecture and technology stack. Just to start at a very high level though, in terms of all of the areas of the Oasis framework and platform and what we actually work on, because it is pretty multifaceted. So I guess the 2 things that we actually build and sort of curate for our community are the blue globe at the top, so a series of standards that you need for building and operating CAT models. So the best examples of those are the data formats around getting exposure information into the models, so how you describe locations, risk, and from an insurance perspective, the policies and reinsurance contracts that sit on top of those. there's then an analogous concept of the results data, where the loss curves, the simulation output, and the sort of groupings of those into different reporting dimensions, because you're often interested in, say, what is my average modeled loss by region or by line of business or by some other attribute of the exposure. We also have a standard around the results. And collectively, we talk about Open Data Standards ODS, which is our set of standards that sit across both exposure and results. And then increasingly around APIs, programming interfaces into other systems. We do a lot of work under the sort of banner of interoperability. How can our software play well with other systems and databases that people are using? I suppose the big red planet then is most of what we're talking about today, which is really the open source software that's the sort of main code offering. So this is the model development kit, the simulation engine to run the models, a user interface, and lots of bits within that. And we'll dive into a lot more detail on that in the coming slides. In the purple at the bottom, lots of different ways of actually deploying the software. So you can have a single server, very easy to set up for evaluation or smaller models. You can have much bigger installations. Increasingly, we're looking at how this is, runs in the cloud with lots and lots of machines working in parallel. And then we have collaborators who either operate the system as a software as a service or as a model on demand, depending on how people want to access and license the models. And then the sort of green planet on the left is really all of the companies and organizations that we work with to provide models. And these are, I suppose, the main independent commercial companies that we work with in this space. And around that, there's, a sort of a group of academics and research groups who are also able to use the Oasis software to build and publish their models. Okay. So getting into the actual software then, and I think it's sort of instructive to start with what are the kind of real key use cases that we're looking at from the software development side, and who are the sort of persona who are going to be using the system. So I suppose the first core one is the risk analyst, so someone who wants to, who has some exposure and wants to understand the risk profile of that. And so they're able to use the Oasis user interface to set up and run analyses. They've got exposure data in our open format, and then they can run models and retrieve results and pull it out. So that's pretty much the kind of core use case. The second one is then we of course have model developers, people who have models that they want to build and deploy into the platform. They use the model development kit, the MDK, to build and test their models, which they can then deploy. And we also have a concept of the Oasis model library, which is a central repository where the published models can be made available. The third and fourth ones then get a little bit more technical. So as a software engineer, I use the Oasis Platform API to integrate models with other risk systems. Especially in our work in the insurance and reinsurance industries, we don't offer a full end-to-end exposure management platform. That's very much not our remit. Instead, it's in the more interoperable world that we all kind of live in the software space. It's all about APIs and plugging together different analytics. So we have a fully functioned API that we'll look at a bit later in order to do that. And then finally, the sort of systems engineers. So especially when you look at bigger systems with lots of models and lots of analyses, there's quite a big sort of operational task around deploying models, versioning them, making sure that lots of concurrent analyses are processing correctly. So again, we're sort of building tools and approaches to help with that. And so that then maps into forming components in terms of the software itself. So the core thing is the actual platform. So this is the data standard, the APIs, the tools, and all of the components for actually building and running the models. And this is the really core part of the system. We then have an Oasis user interface. I think we went over this in quite a lot of detail in one of the previous sessions. And this is particularly targeted at projects such as this one, where we can fully support, the core end-to-end workflow of uploading exposure, running the model, retrieving results, and that's a web-based application. It's a bit simpler, and it's a bit more pared down to say the insurance, reinsurance use cases, where the user interfaces there need to support underwriting processes, portfolio management processes, and we have a much more sort of simple pared back structure, just looking at the core modeling capabilities. The Oasis Model Development Kit, we've talked about that a little bit already, and Ben will be going through that in quite a lot of detail later on. And then this concept of the Oasis Model Library. As I mentioned, we have a centrally hosted catalog of Oasis models running. Both makes this, we can make them available to people who want to use them or license them for commercially available models. The other benefit of that is whenever we do a release, we can actually retest all of the models in the model library, because we want to be aggressively adding new features and pushing ahead with the capabilities of the platform, but absolutely we don't want to be breaking or changing the numbers that are coming out of the models. So we've actually invested quite a lot of effort in the tooling and the framework around performing that sort of regression testing of the models. Okay. So how does this all plug together? So this kind of illustrates the sort of ecosystem that we see. So at the top, you've got a model developer. He's using the model development kit tools, and that's very sort of direct. That's actually working at the command line or very via programming tools to kind of build and calibrate the model. And then once that looks good, you can package up the model data and the assets associated with it and push that into the model library and make that available for users. And then at the bottom, we have either a risk analyst using a user interface to access the platform to run the models, or on the right, you can plug this in via an API into some other system. I think one of the really critical and sort of key ideas of the whole system is that whether you're running the MDK, the platform via the UI, the platform via an API, it's exactly the same data structures, the same modules, the same code that's sort of running everywhere. So there's no refactoring that has to occur between the different parts of the ecosystem. There's no risk that the model outputs that the model developer is seeing on the workstation are going to be different to those that the risk analyst sees, which is a sort of tricky problem for any modeling system, but I think in particular for ours, when we have lots of different model developers, all with different sort of approaches, tooling, workflow, etc. If we didn't really focus on that commonality, it would be very difficult to manage. Okay. And then getting into the sort of technologies we use, obviously by, our approach is very open source. All of our code, as we'll see later, is available on GitHub. So by the same virtue, we try and use open source for the packages and tooling that we use in the platform. We don't want any sort of license fees, etc., associated with running the platform. And we also are invested and believe in open source as a methodology for building, robust, usable software. So what does that look like? So right at the heart, right in that bullseye, we've got an Oasis LMF Python package that you can just download from PyPy for those who have a bit of Python knowledge, which is a sort of open package repository. We do have some C++ code for the some of the core analytic pieces where performance is of a premium, but they're all wrapped within Python. So it's really the Python library that's the sort of fundamental unit. In terms of our platform, what I'm talking about is the enterprise deployment. We have a few fairly standard kind of Python tools. So we use Django for our API and web services. That green C is a framework called Celery, which is about job distribution using message queues. And then, as we'll again see a little bit later, we use a lot of a technology called Docker, which is, very widely used now in all sorts of systems. And really, it's an evolution of virtual machines to provide much lighter weight software containers that can then be deployed into various different types of distributed compute frameworks. The thing that's really nice for us as well is just being a very good and elegant way, an industry standard way of deploying software today. It also allows us some flexibility with supporting more complicated models, because we do deal with some vendors who have their own methodology, their own bits of software, and that might imply other programming languages, even some specific database technologies in some modeling cases. So that can actually all be wrapped in a Docker image and deployed side by side with more sort of canonical Oasis models. But it still takes, those models would still benefit from our analytics, our financial module, our platform engineering. So that's been a really powerful technology for us. At the bottom, we use a lot of Jupyter notebooks for those of you that are familiar with those, and we'll see a few examples of that later on. And our user interface uses the R Shiny statistical language, which is an extension of the R language for building user interfaces, but it means you have access to all of the data visualization capabilities and mapping functionality that you get with the R programming language. On the right, so I suppose everything in the circle is really what we kind of own as an organization. We then work with other organizations to deploy these, bigger systems. So either it can be some of our partners like NASDAQ who are running a software as a service based on Oasis, or it can be some of the bigger insurance reinsurance companies that work with, who obviously have big in-house compute systems. And the sort of technologies they might use are so there's AWS or Azure. You could also add Google Cloud Platform to that. We've operated in most of those. Apache Spark, and that wheel at the top is a system called Kubernetes, which are both becoming increasingly popular and dominant in the sort of distributed computing stroke data management spaces. And we're actually doing projects using both of those technologies. Slightly out of date, this slide, it says coming in 2019. We've just finished the first version of the sort of fully distributed Oasis platform, and that's actually in test with a few clients at the minute with that clip test system using Kubernetes and AWS. So that's sort of more or less transitioned into that more cloud scale rollouts. Okay, so that's the sort of platform at a high level. What does it look like at a slightly lower level? So typically, sort of starting on the left, you start off with, you have your exposure and maybe some results in some sort of a database or results management system. So the first step is that we need to get the exposure and transform it into OED, the open exposure data, which the platform runs against. And I think again, that was covered in some detail in one of the previous presentations. Once you have your exposure in the OED format, you can then push that into the platform via the API. You can then make calls again via the API to configure and launch the analysis, and the API will then broker that analysis into the Oasis backend. So that could all be running on a single machine, and that's the example I'll show in a minute, or that backend could be a distributed architecture running on the cloud, perhaps, just depending on the sort of scale of the system. Once the analysis is finished, step 4, you can then extract the results, again using the API, and then they're available for whatever post-processing or results management that you kind of want to do as a user. So that's the sort of basic end-to-end workflow. What this looks like then is an actual system, and I'll only sort of sketch this out. So each of these little boxes with the kind of little blue wheel, they're all these Docker components. So what they allow you to do is either wire up this sort of a system on a single machine, or they could all be distributed and communicating across lots of machines. It kind of abstracts that away. So in particular, kind of on the right-hand side, we have 3 model workers in this case. So that would be for 3 different models that are deployed in the system. But that could really be as many workers as you need, and could be potentially distributed across many machines. So that's how the system scales up and down. And where that becomes interesting, and what we're sort of looking at the minute, is with cloud platforms, you actually have a lot of potential to sort of auto scale that up and down. So if the system isn't being heavily used, you would scale that right down, so you wouldn't really have any workers sitting about. If then lots of jobs got submitted, you would be able to automatically scale that up and just be using and importantly paying for the compute that you actually need. In the center then we have all the bits around the platform. So we have a database that stores kind of the state of the system in terms of users and jobs. Everything is asynchronous, so we have a series of message queues that kind of control the work. We have a data store that sort of stores the transitory information about running the analyses. So we need to put the results somewhere before they're served back to the user. And then on the sort of left-hand side of the dotted line, we have the user interface that is an option for operating the API. So here's a slightly more detailed version of a description of those components. I won't go through it here, but it's there for your reference when we make the slides available. Okay, so trying out the platform. I wanted to spend 10 minutes just sort of showing you the sort of quickest way of getting up and running with the system. So if I jump back into our GitHub repository, so we're open source, we publish all our code. It's all available through this GitHub Oasis LMF site. And the first thing I wanted to have a look at is this Oasis evaluation repository. And what this does is it's a very simple way of pulling together all of the bits of the platform, installing it on a single machine with an example model, and it's a very quick way of kind of getting up and running with the system. So if we just want to actually launch this, so I just want to clone that repository, and I'll just jump in there. So for those of you who have no familiarity at all with GitHub, it's a it's a central web-based code repository, and you can just pull that down into your local machine. So I've copied that website we've just saw a minute ago, and now I have those assets available on my machine. And as you saw, it was pretty quick. Now to launch that, so I've got none of those little Docker containers that we saw a few minutes ago running. My machine's not running any of those. And then I'll just kick off the installation. Now this will take a minute or two. It's just copying down the models and things like that, and we'll then kick off the local system. So while that's chugging away, I'll just jump back into the GitHub repo for a minute. So there's lots of stuff on here, but the pin repositories are probably the main ones. So we've got the Oasis LMF, which is the sort of core Python library that actually has all of the modeling and analytic code. We then have the platform, which has the, I suppose, more the infrastructure code. So things around the queuing system, the API, all of that sort of stuff. We then have the what we call Oasis PyWind, which is the model we'll see running in a minute. That we need a sort of basic model that we can use for adding new methodologies and having as a sort of reference system that people can play with. So this is a completely fictional model for a windstorm in the north of England, in a town called Melton Mowbray. I think Ben will look at that in a bit more detail later on, but it's really just something that you can play about with and sort of get a sense of how these things wire together. We then have the user interface code, that's the R-Shiny code, and then a repository for the open data standards. So this is something that we're actively developing in a minute, but this will have the schemas, example data, some tooling around it. So that's all available in that repository. We then have lots of documentation. So some of this is bits and pieces we've seen in the presentation up to now. We have some information on the architecture. If you're a developer, some of the repositories, some generic stuff on catastrophe modeling, and then also some stuff on the releases. So generally we release on a monthly basis. And here we have the, the sort of change log and the bugs that were in the latest one. So 183, which we did a couple of days ago, was actually just a patch release, so not much in it. We also have a list of known issues at any given time. It just pulls out the sort of latest bugs, and in particular for the companies that are using it, it's important to know if there's anything, say, in the financial engine that kind of needs looked at. If we just go back into the slide, I think I had one more, and then we can come back to that. So we've just had a look around GitHub. So all the code and documentation is available on the Oasis LMF GitHub. As I mentioned, we've got a monthly release cycle. We had a look at the latest release and the known issues. The other thing, as we were talking about with the model library, we have a continuous integration system. So all of those regression tests for the model library, you can actually view through this website. For those of you who know something about this, we use Jenkins as a continuous integration system. And then the final point is around communication in the team. What's the best way to collaborate with us? And I think the best of those is via GitHub. So I think one of the sort of cool things over the last 12 to 18 months is, it's become more of a collaborative project. We've started getting commits back into the repository from the community. So I think as far as possible, using GitHub as the mechanism for communication, so you can go and raise issues, raise questions, directly on GitHub, and the team will have a look at those and answer them and prioritize them. We do have a support email as well, support@oasislmf.com that you can route questions through. And then Slack. So Slack is pretty widely used kind of chat messaging system. So we use that internally a lot, and what we find is if we're doing a project with another company that's somewhat ongoing, it's a great way of, if you set up a Slack channel of having back to forth through a sort of model development or deployment project, we find that to be a very valuable way of communicating. Okay, so that's all done. I'll just list this out. So here we go. We've got all of these Docker containers running now. So if we think back to that diagram we had a few minutes ago, just scroll up. So each of the lines really corresponds to one of these boxes. So what we've done is basically deployed this entire system onto my local laptop. So that's all running and available to play about with locally. So the first thing I wanted to look at was the API. Okay. So along with the evaluation, we have a series of these Jupyter notebooks that allow you to sort of play about with the system. So this first one looks at using the API directly. So the other thing, and again, those that are maybe more familiar with APIs, if I just copy that, go here. So there's a full Swagger set of documentations available that you can look at. So this gives both a description. So we have endpoints for querying analyses, kicking them off, getting data files, models, etc., etc. And this also allows you to try out the commands directly. So this is the sort of standard way that APIs are sort of documented and published. But we also have this little client tool that allows you to run it directly. So this basically just sets up a Python client to the API. We've talked about OED. We have these 4 example OED files. So the location, account, and tree reinsurance files. First step is then to upload those into the platform and create a portfolio. You can list out the models. So in this system, we've only got that example Oasis LMF PyWind model registered. I've got a few details about it. If I look at the portfolios, I've got the demo portfolio, which I just set up in the command a few seconds ago. And now I want to create an analysis. So an analysis in the system is really a combination of a portfolio and a particular model. So I can just create that. And there we go. We've got a new analysis created. Now, when you actually come to run the analysis, it's a kind of a 2-step process. So the first one, which I'll just kick off, is what we call run generate. And what this does is it takes the exposure data and kind of combines it with the model specific data. So more specifically, it will take the lat longs of the locations and map those into the grid that you use for that model. And it takes the exposure characteristics and maps them into whatever vulnerability library you've got for the model. And I think Ben will go through that in a lot more detail. So once that's run, you're basically ready to execute. So I'll kick that off. So that's actually going and running an analysis. And then once that's done, so that's returned true, the results are then available that you can go and download those and kind of interact with them. And just to show you the sort of how that links into the UI, which again, I think you saw in a previous. So this is the user interface running against the exact same Oasis backend. to log in, so it's admin password. So here we have, this is the analysis that we just ran via the API. Cancel that. And here's the EP curves, loss metrics, etc., that were generated by that results. So, you can either work via the user interface, it's a bit easier, or you can jump into the API world, running exactly the same thing against exactly the same back end. There's just the sort of two ways of kind of operating the system. In addition to that, you can also use the MDK and run it all much more directly, which I think is what I'm going to hand over to Ben to talk about now.
Okay, thank you. Let's see if we can switch screens smoothly enough.
Stop that.
Thanks a lot, Mark. Yeah, my name is Ben Hayes, and I'll be going through a little on the model files themselves, how a model is structured in Oasis, which might be of interest, and then talk through the MDK. And we'll go through another example of one of those Jupyter notebooks where we actually see the files and run the MDK against the PyWind example model that Mark's already touched on. Okay, on the wrong screen. So, there we go. Okay, so Oasis is effectively a kind of plug and play set of software where we can plug in different bits of data and run models against it. And the three modules that we're really interested in are the hazard module, representing the event sets themselves and their footprints, the vulnerability module, representing how exposures would react to particular events, and then the exposure module, which defines the exposure data itself that we want to run against the model. So we'll go through each of these in turn. I'll start with the hazard, go on to the vulnerability, and then we'll touch on the exposure quickly. So as an example here, I built a little demonstration model around Manila, a flood model to kind of fit in with this project. So we can imagine we've got two flood footprints, so two synthetic representations of floods that affect Manila. Here we are, we've got pictures of them. And then what we actually have to do to make that work in a model is break those down, because Manila itself is obviously quite large. The whole country is much, much larger. So we need to say, how did this particular event affect particular sub-areas? So we introduced the concept of what we call area perils. And these are just breakdowns of the wider area into sub-areas. And these can be whatever scale they want. In the Oasis terms, it's a complete abstraction. It's just a number representing an area. So in this example, I've done quite a simple uniform grid, but that could be a variable resolution grid. The areas could be postcodes, they could be administrative regions, they could be whatever we want. To keep it simple for this example, I've just built this grid of 20 cells covering the whole of Manila. And then what we want to do is see how those two things overlap. So we've got our two events that we've invented, and we've got our 20 grid cells that we call area peril IDs. And our footprint, our Oasis representation of that event set is really just a combination of those two things. So we can see here we have a file, a kind of discretized file that says for my event number 1, which was my big cell, big oval over here, in area peril number 1, which was my upper left cell up there. For a particular intensity, I have a certain probability. And this is a fairly simple example. So everything has point probabilities, uniform 100% probabilities. But my intensities here, you can see, are just numbers, and they map into some reference dictionary file over here. So what this is telling me is my first event over here in that cell has 100% probability of some range of inundation depth for this flood model. So I've got 0 to 20 centimeters. And my event number 1 here in this cell, cell number 2, has 100% chance of intensity 5, which is, oh, sorry, I was saying 40 to 50, 50 to 60. So I've got some representation of how bad the bad the event is going to be in any one cell. And I can build on top of that. So I've got many, many events down here. And in practice, these can get very large. We can have tens of thousands or hundreds of thousands or sometimes even millions of events, depending on the particular peril. And the area of peril spread can get quite large as well. So these files can get very big, but the Oasis Loss Modelling framework is designed to deal with these very large files efficiently. And helped by that is this complete abstraction of all of the concepts. So our events are just numbers, integers, our area of perils are just integers, our intensities are just integers, and the probabilities are float values, but in this case they're integers. But then, you know, it's a fairly abstract representation of a model. And it also means we can be kind of peril agnostic in this term. So the fact that this is a flood is, we know it from the model, but it could as easily be a windstorm or an earthquake or anything else. These events are just integers representing events. The areas are just some spaces on a map, and the intensities represent some abstracted integer representation of an intensity. These could be wind speeds, they could be peak ground accelerations. The point is the Oasis representation of a hazard is really this here. Okay, so that's how we represent hazards. And going on to the next part, which is vulnerabilities. So again, we kind of discretize and build probability distributions to represent the uncertainty in these things. So this is an example of a fairly simple vulnerability function. Important is that we've got common intensity bins. So on my previous slide, I had the idea of intensity bin 1 was 0 to 20 centimeters, 2 is 20 to 30 centimeters in dation depth. So on my vulnerability side, I also need to have the common intensity bins. I'll show you why in a second. But this vulnerability function is telling me that for a particular type of building, I have for intensity bin 1, which was 0 to 20 centimeters, I have 100% damage, 100% chance of 0 damage. And as my intensities increase from 20 to 30 centimeters, 30 to 40 centimeters, my probability of more damage increases and my probability of 0 damage decreases with increasing intensity, as you'd expect. And the way we represent that again is through a very similar looking file. So we have many vulnerability functions up here. And these can represent different types of properties that would map in, similar to what Mark was talking about earlier on. So we have different vulnerability functions representing, say, residential 1-story buildings, residential 2-story buildings, commercial buildings, industrial. These can be as complex as you like. You can get many, many thousands of those, or you could have a relatively small amount, depending on how much you know about the infrastructure in the country. We've got our common intensity bins that we talked about. And then we have this concept of binned, discretized damage functions. And so we're saying damage function 2, bin 2 is some damage from 0 to 10%. So these represent the colors on our charts. So this chart represented in Oasis terms has, for each vulnerability, for each intensity bin, for each damage bin, a probability distribution of the combination of those three things. So this table is the equivalent for our vulnerability ID 1 of the chart that we built up over here. So I can see vulnerability ID 1, which we're looking at, intensity bin 1, damage bin 1 has a 100% chance. Intensity bin 2, which was our second chunk over here, damage bin 1 has a 90% chance. So that's our 90% bar there. And then a 9% and 1%, which are 9s and 1s. So we're really just saying how we represent the probability distribution of damage for a given intensity, set of intensities for a particular vulnerability function or type of problem. So that's how we represent vulnerability and hazard in Oasis model. And obviously we can have many, many more vulnerability functions down here. So we have lots of these charts that scale into additional numbers down here. And then we can bring it all together, and this is why we need the common intensity bin definition. So we've got our hazard bits on the left that we saw earlier, and vulnerability bits on the right we just saw, and they really connect through this common intensity bin. But this, as we see it here, is a full model in Oasis. And as I alluded to earlier on, the files themselves can get very large. The footprint tends to get very large. In particular, vulnerability can get very large. The dictionaries, not so much, but Oasis is designed to deal with those very, very large files. And these can get into kind of towards a terabyte, some of the running models we're running, we're supporting. So the third part of that, on top of hazard and vulnerability, is the exposure data. Mark's already talked a little about the Open Exposure Data Standard, which is what we support here. And he's touched as well on this idea of a keys service, a lookup service, which maps exposures from the Open Exposure Data Standard into these keys, as we call them, which are the area peril and vulnerability IDs, which are how we map into these footprint and vulnerability files, because these are keyed effectively on area peril and vulnerability ID. So our keys service takes some kind of exposure data, and it might, in this case, take, you see like lat longs there, and place those inside a grid cell to give us our area peril ID. It might take our occupancy code, which tells us something about whether it's a residential or an industrial or a commercial property, and the number of stories to map into some kind of vulnerability ID. If you remember up here, we had our different vulnerability IDs representing our different occupancy types with some additional secondary modifier in there on stories. So we can take our kind of human readable exposure data and map it into a model specific representation of that data, which is using the area peril and the vulnerability IDs to see how we plug those bits of information together. So those are the three components very quickly there, and we'll share these slides around. I'm conscious I've gone through that fairly quickly. But we've got, importantly, the hazard, which is that big event footprint. We've got the vulnerability, which is a set of probability distributions for intensities across building types and damage. And we've got our exposure data, which is really a mapping of Open Exposure Data Standards to the model-specific representation of area peril and vulnerability IDs. So going on next to the model development kit, which Mark has talked about. The model development kit, I think you're probably aware now, is a Python package and a command line interface to run these Oasis LMF models. It's generally used to help build and test, in some cases run models directly in Oasis LMF. It's very, very easy to install. We have a Python package which is published and open called Oasis LMF, and you can just use the Python installation package manager pip to just type in your command line, pip install Oasis LMF, and it will pull everything that you need to run stuff locally. The workflow itself, which might be new to you, but the general idea in running an Oasis model is there are two stages. One is preparing the data, and one is executing the analysis themselves, the full kind of Monte Carlo simulations. So if we go through this from left to right, typically we will have some kind of exposure data, which we push into the system. We run a process called generate keys, and we'll go through this a bit more later on, it'll make more sense. And that looks up that data. So what we've already talked about a few times is we're taking some human readable exposure data, we're looking it up against the particular model with the keys data that runs those lookups, and we get back out of that these keys files, which tells us for every location that we've entered, what are the area peril and vulnerability IDs, except for where there is no mapping. So it might be that we put in some locations that aren't covered by the model for some reason. We also get out in these keys files a set of what we call error files, which are, this location is not in the geographical realm of the model, or it's not a particular type of occupancy type that we cover in this model. So importantly, you get some information here about, of your input exposures, what is actually going to be modeled or not. But the main output from this is that mapping of these exposures to the abstract keys of area peril and vulnerability ID. These can then be pushed in along with the exposure data itself to what we call the generate Oasis files. and this generates a kind of very abstracted view of the exposure data just with abstract IDs in it. So we've got area peril IDs and vulnerability IDs and insured values in these, what we call the Oasis input files, which actually go into the core calculation kernel itself. These are very far from human readable generally. They're just lots and lots of integers together, which work with the model and are very efficient, but are not very easy to read. So this is generally kind of available, but not advisable to delve into too much unless you really know what you're doing. And these very abstracted input files are then passed into a process in the MDK called generate losses, which touches then those big footprint and vulnerability files with our abstracted input files and runs the full Monte Carlo simulation and generates the outputs that we're requesting in our analysis. And then we get the output files, which we saw in the UI there and through the API, which are things like average annual losses, loss exceedance curves, event loss tables, those kind of things. So we have three real processes there. We generally bucket together this generate keys and generate Oasis files into what we call model preparation, and then the generate losses is model execution. And these are the command line requests that we can pass into the MDK. We also have an overriding command line request just called run, which will run all three together. If you point it to your exposure data and you point it to the keys that you want and the model data that you want, we'll see an example of this in a second. We can just use a very simple command in the MDK to run the whole process end to end and get some output files. Just jumping into it now. So the Oasis LMF, the MDK itself is a command line interface, generally follows the pattern of Oasis LMF with some subcommand and then a set of options. Every subcommand and indeed the high level LMF has this -H option, so we can always run, like you see in the example up here, Oasis LMF -H, and we get a lot of options of what the subcommands that can follow it. If we then moved on to Oasis LMF model -H, we can see the options that sit behind that as well. And some of these were just what we were seeing in that workflow diagram there. So we've got generate keys, we've got generate Oasis files, and we've got generate losses. So if I wanted to run any of those processes individually, I could just do Oasis LMF model generate keys, and it would generate the keys. Oasis model runs the whole thing. So if you remember my workflow, the run encapsulates all of the underlying processes. So the MDK really is, once you've got the bits in place, it just allows you to run the entire end-to-end system from the command line on a local development environment. And importantly, these are all the same components that go into the deployed version that Mark has demonstrated already. So we can be fairly confident that whatever you run in the MDK will run exactly the same in a full Dockerized deployment version of those components, because it's all the same underlying code underneath. You know, the deployed environment just allows you to run much larger analyses on big machines or distributed machines. Generally, the MDK is used on a kind of local development environment, which is a bit smaller. There are a couple of files that are worth mentioning that are important for the MDK. One is what we call the config file, and this is something that points the package to all of the relevant bits that it needs to run. So when you might have seen, an example of it? No, but let's just going back to our workflow. When I said we can run the whole thing, but we need to know where the exposure data are. Oops, sorry, clicked. Where the exposure data are, where the keys data is, where the model data is. The config file allows you to set all of those in a quite a clean JSON file. So just jump back to it. So this has got a lot of information in here, for example, show me where the lookup data directory is and where the model data directory sits. And then when I want to run something, I can just do Oasis LMF model run with a -C flag to this Oasis LMF JSON config file that I've highlighted here. And that just allows you to run the entire end-to-end process using all of the bits that are highlighted in this file. Just allows you to keep all of your test data in one place. And you can have a number of those files for a number of tests with different location test files and things. But it just helps to keep it quite clean and consistent, rather than detailing every sub-option in every command run. And the other one that I'm going to point out is quickly as well is this analysis settings.json file, which is pointed to within the config file, and this tells the framework what it wants to run. So we've got a few options in here. You see how many samples we want to run against the Monte Carlo simulation. We've got a few things on here on the type of outputs we want, whether we want average annual losses, event loss tables, loss exceedance curves, and different types of loss exceedance curves in there, and a few kind of runtime parameters that are important for this particular execution. So in the deployed version of this this workflow, this is the kind of thing that's generated by the UI. So you've had the UI demonstration already, and you've seen where you go in, you select how many samples you want to run and what outputs you're interested in running. This file is generated by the UI and passed into the API. In the MDK, you don't have a UI for that, so you generate this file yourself just to test different types of runs. Okay, so that was the end of the presentation. What I was going to do now, hopefully, if I can find, where's my screen gone? I lost it. Give me a second. Here it is, hiding behind. So I'm going to go through another Jupyter notebook, and this Jupyter notebook is, Mark's already shown the high-level Oasis LMF GitHub repository. There is this Oasis PyWind model within there, and you can clone that in the same way that Mark cloned the evaluation repository earlier. Just go into here and you can copy this out and do a git clone locally. This will pull all of the PyWind example model and a few additional tools as well. So on top of what would normally be in a model, we do have a few things to exemplify what we can do. One of them is this Jupyter notebook here. So I pulled it, I set it's running. And this is the Jupyter notebook that we'll run through quickly now. Okay, so let's give it a go. So we can run through a few of these steps. So what we're doing here is just setting up some of the libraries that are used inside the notebook. And we'll go through and have a look at some of the files first of all. So I've been through the presentation, showed the types of files that we have. This is for PyWind, the example area peril dictionary that we use. So we can see we've got different area peril IDs here, which represent grid cells. We've got lat longs of the, in this case, the vertices of those grid cells, and a little bit more complicated, but this particular model covers multi-perils as well. So the demonstration in the presentation was just a single peril, but we can stack perils on top of each other, and they can have different grid cell representations of how risk affects properties. Okay, so that's what, so we'll go through a few of these files just so we can have a look at what they look like. Let's go down a little bit. Doing that. Yeah. So I think this will take a second to go, but this is just this is using a little Python library called Folium to graphically represent this file. It takes a few seconds just to render, and then I should be able to set that one going as well. So we can see here that this is kind of, Mark said, it's a PyWind is a toy model that sits in Melton Mowbray. We can see what the grid cells look like inside here. So these are the grid cells that are covered. I think it's probably not resolving itself very well at such a low scale, but the grids do meet up at the corners. And you can see that in the data up there. So all of this is just to show what some of the data looks like underneath and visualize it. Okay, so we'll go on from that and we can have a look at the intensity bin dictionary, which was the important part that I said that connects the hazard and vulnerability files. So This actually, I say it's important, but it's not actually used in the calculation kernel itself, so it can take whatever form you want, but it's very important that it's consistent across those hazard and vulnerability files. Okay, so a quick look at the footprint. So the footprint's very similar to what we saw in the presentation. We've got events, we've got areas, we've got intensities, and we've got a probability distribution across the combination of those three things. These, again, are all point values, so they're all 100% probabilities, but they can be more complicated than that. They can be separated out into full distributions. And we can have a look here again, just using Folium, I think, is it using again, to actually visualize what these footprints look like. So similar to my crude pictures of ovals representing floods, this is an actual representation of how intense these particular windstorms are across the cells within our model. So I can see that this particular windstorm kind of goes up the kind of northeast corner of the model. Event ID 4 seems to be very low and doesn't really affect the area we have here at all. But it's just to show, similar to what we had before, a representation going back from this file to a graphical representation of the intensities. Going on, we can have a quick look at damage bin dictionary. This is something we saw as well. So this is how much damage we have, so 0 to 10%, and then interpolation point. Our vulnerabilities will be fairly similar to what we saw before as well. So we've got different vulnerability functions. And for each intensity, then we have a probability distribution of different damage amounts across those. And these damage amounts are what we saw in the damage bin dictionary up here. And just to show some of the vulnerability functions, again, we've got a little graphical representation of this. So for different intensities, for different damage functions, we've got a probability distribution which sits across different damage factors per intensity. And we can see there's a general kind of curve up there. This is all, I'm conscious I'm rushing through this, we haven't got much time, but it's all open, as we've said already. So you can pull this Git repository yourself and have a run through and have a look at actually what each piece of code is doing. A lot of it's just visualization to make it a little clearer. Okay, so going on to the exposures, we've got, again, an OED file representing some information about our locations. And what we didn't touch on in the presentation is we have an additional option of an account file, which can detail some of the insurance terms and conditions that would be applied over and above location level terms and conditions. So these might be aggregate conditions that are applied across, say, a group of locations that sit under a single account. And we haven't really touched on that at all, but there's a whole financial module within the Oasis LMF which applies insurance terms and conditions. So going on to the more interesting bits, in the MDK itself, we've got a representation here, so we can see our analysis settings, which we just touched on at the end of the presentation. Tells us how many samples we want to run, the different type of outputs we want. They say this would normally be generated by the UI, but if you're running at the API directly, or if you run the MDK, then you need to generate this file yourself. There are schemas published as well within the repository to show you exactly what format that needs to take. And then we can run the MDK, which is similar to what we've seen already. So this is running exactly the same thing that Mark ran through the API and what you've probably seen run through the UI directly as well. But this is running it now with that command that I mentioned already. So Oasis LMF model run -c with the Oasis LMF JSON config file. There's an additional parameter here telling it where to output the output files to, where to dump them, but that's not a required option. If you don't select that, it will just generate a file and name it appropriately. Okay, so that's gone through all of the steps, and we can see some kind of logging here of the model preparation. So we can see it was getting vulnerabilities, it was generating the input files. So all of the bits that we saw in that workflow diagram that I showed earlier on are going in here. A few extras as well. So IL is insured loss. So we're running the financial terms and conditions as well on top of our ground up losses. And then we're still preparing data down here, and then we're actually executing the model. It tells us it's run completed successfully and dump the outputs out here. And then we can actually go in, we can name this file, and we can go and have a look at some of those. And all the files are loaded into that place. And this is just a little graphical representation of the EP curves for the return periods that we've defined in this representation. So that's really it. The real interesting part, I think, from an MDK point of view is just this Oasis model run-c. That's running the entire model from the command line. I say from the command line, it's running from within this Jupyter notebook, but you could just run that from the command line and get exactly the same things. Actually, we could try that now. Let's try copying that out. See if we can open one up. I'll just blow this up a bit to make it a bit bigger. So hopefully you can see that okay. So if I go into my Pywind repository I've got and just run that, it will run dot is then run it from within there. So I can run the same thing from the command line there. And it'll take a second to run through. And then, as I said, because I didn't specify an output location, it's just generated one here. If I go into that one, I can see inside my outputs there, I've generated a load of files there. I can have a look at my AL calcs typos, and I can see my average annual loss calculations that have just been generated there for it. Okay, that's it. I'm conscious we started a little late, and I think we've about kept to time, but we were going to keep some time at the end for questions. So should I hand back to, is Julia still there, or Claire, do you want to facilitate the questions?
So yeah, we've got one question, probably best for you, Ben. Should I just go
Sure.
ahead? So there was a question. Says if an area peril bin gets a value of 10 to 20 centimeters, does that mean the whole area is inundated by 10 to 20 centimeters?
Well, it does if you have that 100% probability. But if I can just jump back, let's look at my presentation running. One sec. Let's just go back up to that bit. Look around. So yes, if we have a probability of 1 here, but if we have a full probability distribution here, then it will be a stochastic calculation of, if there's a 90% chance of 0 to 20 centimeters and a 10% chance of 20 to 30 centimeters. When you run it, it will be at runtime, it'll be a random selection of one of those things. Now, if these cells that I've drawn here are obviously quite broad, but I think I mentioned that they don't have to be uniform, they don't have to be a certain size, they can be variable resolution. So I think in the model that we're working with cat risks on doing here, I think they're looking at a 10-meter resolution, so it would be much more fine grained than this. You can, in Oasis terms, it can be whatever you want. It becomes a data problem at some point in terms of the scale if you go down to a very fine granularity of resolution. But yeah, this is a very simple example, and it's not appropriate at all for the entire of one of these cells, obviously, to be the same inundation depth. Normally, if you had a big cell like this, you'd have a probability distribution across it, or you'd break it down into much, much smaller cells, which again can be a variable resolution grid. So you might have very small cells around the coast and along the river, and then much broader cells up in the hills for a flood model. But if you have very fine, kind of close granularity cells, then this concept of 100% probability of 0 to 20 centimeters within a very fine cell is more realistic. We do still have the uncertainty that's covered over here on the vulnerability side. So even if you have a fixed inundation depth for the flood in a particular cell, we still, in this case, have uncertainty built into how much damage it would cause. So you can handle it that way as well, which is sometimes more efficient than building uncertainty into both, or secondary uncertainty into both the hazard and the vulnerability. You can just, pile it all into the vulnerability file, which is generally much smaller, and you can circumvent the data size problems there. Hopefully that kind of answered it. Kind of rambling answer. If you have any more questions, you can contact us after. Or I think we'll be publishing our emails. Is that right, Julia? To send more questions if people have them after.
Yes, exactly. So yeah, thank you, Ben, for answering the question. And yeah, you feel free to send us your questions to support@oasislmf.org or directly to Mark or Ben. We will send you an email after this meeting with all the relevant details.
Okay, is that all the questions?
I think, yeah, that's it. So thank you everyone for joining today, and we hope to see you at webinar 3, which will be in July. So you will receive as well, again, all relevant details by email. Thank you very much.